Albert Einstein initially dismissed it as utter nonsense, but after researchers uncovered more and more evidence about 100 years ago that the universe is not a static, unchanging entity, even the creator of the theory of relativity had to admit that he was wrong. The discovery of cosmic expansion is inextricably linked with the name Edwin Hubble to this day, no wonder, since the young US astronomer was the first to recognize the true nature of a strangely flickering distant star and prove that the Milky Way is not the only galaxy in the cosmos. Ultimately, Hubble's revolutionary findings thus also paved the way for the Big Bang theory. And yet, this is only one side of the astronomical coin, because the truth also includes the fact that the expansion of the universe is still overshadowed by huge question marks and that it sometimes presents the experts with unsolvable problems. There are some things that are simply part of the basics of astronomy. According to established doctrine, the universe was created about 13.8 billion years ago in the much-cited Big Bang, and it has been expanding relentlessly ever since its birth. But if we turn back the wheel of time a good 100 years, or more precisely, to the year 1917, we see that even the greatest luminaries of physics in history once held a very different view of the world. In fact, a certain Albert Einstein was initially firmly convinced that the cosmos neither expands nor collapses, but rather embodies an entirely static construct. A literal beginning of everything seemed simply inconceivable to Einstein, and so it came about that he even expanded his field equations to include a cosmological constant after initial doubts about his work suggested that the universe cannot remain rigid and unchanging forever. While some experts adopted Einstein's constant into their calculations, the astronomical revolution had long since begun. At the other end of the world, the aspiring astronomer Vesto Slipher of the Lowell Observatory in Flagstaff, Arizona, devoted himself to the task of understanding the movements of the mysterious spiral nebulae. In the course of this, Slipher also considered a possibility that was in stark contrast to the ideas of his colleagues. Could it not be that the mysterious formations are structures that lie outside the Milky Way? Why this assumption seemed unusual, even cautiously formulated, becomes clear to us when we consider that at that time the Milky Way was thought to be the only galaxy in the entire universe. But as we now know, the observations by Slipher and his colleagues were to shed a completely new light on our cosmological worldview, and that is meant quite literally. After all, even the astronomers of the early 20th century knew that the light spectrum of an object reveals whether and at what speed it's moving toward or away from us. For example, if a star is heading towards us, its electromagnetic waves are slightly compressed, and its light spectrum is shifted towards the short wavelength blue end of the spectrum. If, on the other hand, a star moves away from us, its radiation is stretched and, as a result, redshifted. The catch, however, is that we need to know the original light spectrum of the star in order to understand how much it has been shifted into the red or blue. Indeed, Slipher managed to develop a solution to this complication based on the discoveries of Joseph von Fraunhofer, Robert Bunsen, and Gustav Kirchhoff. The spectrum of light contains not only spectral lines but also dark lines that originate from elements that absorb the corresponding part of the radiation spectrum. Since it was known at which wavelengths the lines usually occur, Slipher recognized in them a fundamental key to the spectral shift of celestial objects. With this in mind, the astronomer carried out initial investigations using a spectrograph installed on a telescope, taking a closer look at the Andromeda Nebula, M31, without knowing, however, that he had just caught a glimpse of our neighboring galaxy. How Edwin Hubble shook up the astronomical world. Despite all this, Slipher was able to uncover some basic characteristics of these spiral nebulae. For example, we now knew that they appear to rotate on their own axis and that M31 is moving towards us at a speed of 300 km per second. In detail, however, the Andromeda Nebula also broke the pattern observed by Slipher. The other nebulae examined were all supposed to be moving away from the solar system. At the time, Slipher had no idea what an extraordinary moment this discovery would prove to be for the entire field of astronomy. This only changed when a certain Edwin Hubble came on the scene soon after. In fact, he had been committed to the goal of finally uncovering the true nature of the mysterious nebula structures since 1919. The majority of experts saw them as objects within the Milky Way, no wonder, since, as mentioned, it was considered the only galaxy in the entire universe. At the Mount Wilson Observatory in California, however, Hubble wanted to find out how far away the mysterious structures were. In the best Slipher tradition, he set his sights on the Andromeda Nebula, M31. But even in the world of astronomical upheaval, the assistance of chance is sometimes required. When Hubble compared a series of photographs of the nebula in October 1923, he was surprised to notice a striking point of light that changed its brightness at regular intervals. Indeed, such flickering light sources, known to experts as Cepheid variables, are still considered outstanding reference points for determining distances in space. Even in Hubble's time, it was already known that the brighter a Cepheid variable is, the slower its rate of brightness changes. Thus, the recurring pulsation of these stars tells us how far away they are from us, regardless of their true brightness. In the case of the flickering star that Hubble discovered in M31, this circumstance ultimately led to a sensational result. According to his calculations, it had to be around 900,000 light-years away from us. But how does that fit into the Milky Way, which is only about 100,000 light-years across? Well, not at all, which is why Hubble came to the only correct but still so revolutionary conclusion: the celestial body must be outside our galaxy. The rediscovery of the universe. And yet, this was just the beginning. As a result of further observations, Hubble discovered that the spiral nebulae had been classified incorrectly all this time. Just like siblings of one another, they were by no means just nebulae or gas clouds but independent galaxies. Hubble's findings led to the known cosmos expanding enormously in one fell swoop and to the boundaries of the universe shifting into unknown realms virtually overnight. Shortly afterward, Hubble began to determine the redshifts of these island universes, and then sort them according to distance, size, shape, and brightness. He noticed a remarkable pattern: the farther away a galaxy is from us, the higher its redshift. In other words, the farther a foreign star system is from us, the faster it moves away from us. It soon became clear that the relationship between redshift and distance could be described by a constant, which Hubble estimated to be around 500 km per second per megaparsec. Even though we now know that his estimate was far too high, his findings represented nothing less than a cosmological revolution. For the first time, a researcher had recognized that the universe is expanding. However, this drastic paradigm shift was not met with universal approval by the rest of the scientific community. Although the Belgian priest and physicist Georges Lemaitre had already proved that an expanding cosmos is not in contradiction with the general theory of relativity, Einstein initially clung to the idea of a static universe. After a meeting with Hubble and British astrophysicist Arthur Eddington in 1931, Einstein finally agreed that the universe could have begun to expand at some point. However, when it came to the cosmological constant, he backtracked, calling it the biggest blunder of his life. It would take more than 50 years before it was proven that this constant is important after all. Even today, the universe's accelerated expansion remains a mystery, attributed to an unknown force we call dark energy. But apart from the fact that it seems to exist, we still don't know much about it.